Hello and welcome to my presentation for managing machine learning projects. The topic I have chosen is on enterprise level invoice payment delay risk prediction. I will be walking through this use case using the opportunity evaluation, the crisp DM business understanding, and with validation planning, system design, and production considerations. First, the opportunity evaluation. Here, the problem I'm addressing is predicting late payment risk for invoices at a large enterprise level. Large companies issue thousands of invoices across diverse regions and industries, and late payments tie up significant work capital and complicate cash flow forecasting. So why is this a good ML opportunity? First, the question is if there's a problem, and yes, late payments are costly and operational pain point that manual scoring can't address effectively. The second criteria, can machine learning help? Also yes, because machine learning can analyze complex historical data to generate risk scores, outperforming static rules. And third, does someone care? Absolutely. Finance teams, credit managers, and executive, even investors all care deeply about cash flow predictability, making this a valuable, impactful use case. Next, crisp DM business understanding. And the business objective is to improve cash flow predictability and reduce working capital, as said before, and which is tied up in overdue invoices by proactively prioritizing high-risk accounts. The data mining objective is to build a machine learning model that predicts the probability an invoice will be paid more than 30 days overdue using structured account receivable data. Success will be measured with outcome metrics like reducing late payment rates, lowering days sales outstanding, which measures how long it takes to collect payment, and freeing up cash flow. For output metrics, I'll track model ROCAUC, which measures how well it distinguishes late versus on-time payments, along with precision, recall, and probability calibration. Relevant factors include herein invoice details like amount and terms, customer profiles, payment history, contract terms, seasonality, macroeconomic indicators, and any prior collection actions. For the solution validation plan, the proposed solution is a machine learning model that predicts late payment risk for each invoice, giving finance teams a prioritized list for collections. To validate it, I would start with baseline comparison against existing heuristics, such as the average payment days or invoices with payment terms net 60 or net 70, so they're actually higher than regularly payment terms and would qualify them as high-risk invoices. Further on, I would use offline evaluation, withhold out data to refine features and model type, and then I'd gather user feedback from credit teams to ensure the scores align with expert judgment. And finally, I pilot the model in production, scoring new invoice in batches and measuring real-world improvement in collections and cash flow forecasting. For the machine learning system design, there are three key decisions to be taken. First, cloud versus edge. And I'll use cloud deployment since account receivable data is centrally stored in the ERP system. Latency isn't critical, and the cloud allows easier scaling and maintenance. The second decision is offline versus online learning, and I'll use offline learning here, retraining the model monthly or quarterly. The payment behavior changes slowly. So scheduled retraining is simpler and ensures stability while still adapting to trends. And thirdly, batch versus online prediction, and I'll use batch prediction here, scoring invoices daily or weekly. Real-time scoring is not needed because invoices are issued and processed in batches, usually. And finance teams plan collection usually on regular cycles. So batch processing aligns perfectly with these workflows, making it simpler and more cost-effective. And finally, the potential risk in production. A key concern is here data drift. So as customer payment behavior can evolve with economic conditions, so regular retraining is essential. There's also risk of training serving skew if features used during training aren't consistent at prediction time, so requiring careful validation and engineering. Latency, as mentioned before, isn't a major issue with batch scoring. However, I think we still need reliable infrastructure to ensure daily or weekly jobs are completed on time. And to mitigate this risk, I'll implement model monitoring in production. And the function is to detect drift, track prediction quality, and trigger retraining as needed to maintain accuracy and trust. Thank you for watching my project presentation on managing a machine learning solution for enterprise invoice late payment prediction. I hope this clearly demonstrated the opportunity, business understanding, validation plan, system design, and prediction consideration for successful machine learning deployments.